Good afternoon, everyone. My name is Ifoma Iwebunam, and I'm here to lead us on today with the time series methods of research, how to use time series method in conducting research. I'm being joined by Professor Robinson and Dr. Stone. Um, In this lesson 4, we are going to continue from where we stopped in lesson 3 to understand how we can apply time series data in our regression or in our research. So starting from here, we need to, in the introduction, we need to know what time series data entails. How do we use time series data in economics research? And time series data measures the events and changes over time. It records it. It's a data that contains the events and changes over time, which we apply to in our regression during research. So it's one of the oh my God, what's wrong with me, Former? Okay. Okay. So time series data in economics helps us to measure the events and changes over time within a data we are using in our research. So the data has to be similar, and then the observation and or the data has to be collected at a fixed interval over time. It can be weekly, monthly, quarterly, or annually. So in time series modeling, or when using time series data, we need to do what is called time series modeling, whereby we do the model specification of the data we are trying to analyze in the research. So the specification of the models has to include whether the variable is dependent. It shows us whether the variable is dependent, that's exogenous variable, or independent. And within that model specification, one needs to be careful in order not to over specify the model or under-specify the model. Over-specification of the models involve or happens when we have maybe two similar variables that can explain the same event, the same time, in the same analysis, and using them can lead to maybe the problem of multicollinearity or serial correlation, depending on the type of analysis we are trying to conduct. Then when we under-specify the models we use in time series analysis, it can lead to also misspecification, in the sense that most of the variables that are supposed to be included in the model are not there. And so we will not be able to get all the information we are seeking for in the research we are conducting. So we need to be careful when selecting our variables in time series analysis, so that will not make any of these mistakes. Again, okay, I've already said that. Then in time series analysis, the model can be correlated. But even though the model are correlated, it does not mean that um, each of the model causes each other. What do I mean here? Assuming we are trying to measure the impact of government expenditure on economic growth, obviously, theoretically, government expenditure is supposed to lead to economic growth. However, that the variables are moving within the same direction, that maybe we establish a relationship within the variables, does not imply that maybe government expenditure leads to economics growth automatically. there is a way we need to measure it to be able to make sure that, yes, the estimates we are trying to measure really correspond, and therefore there is an effect or causality moving from government expenditure to economic growth. So it's very important for us to be able to, to check and demystify that the regression, and make sure that we are not taking correlation for causality, especially when using time series variables. Also, in time series analysis, there is simple linear regression. This simply implies that one independent variable, we have one independent variable and also one dependent variable and one independent variable, whereby um, maybe we check the effects of the independent variable on the dependent variable. One needs to also be careful when selecting the time series data to be able to make sure that we have already dictated, or we've already um, we know what variable we would need to have as the dependent variable. Like I've said, in the issue of measuring whether government expenditure affects economic growth. Obviously, economic growth is the dependent variable here. And then with the government expenditure will be the independent variable. So we need to be able to measure whether, first of all, there is a relationship that exists between government expenditure and economic growth. That's between the two variables when we are trying to conduct simple linear regression just between two models. So we need to make sure that we look at those models and be able to dictate which one stays and as the dependent variable and the one that stays as the independent variable in order for us to achieve the maximum result we need for our regression. Then the simple linear regression model can be specified, like I said before, when we are using just two variables, especially in this case, where we have student test score and as the dependent variable, is always assumed that the number of hours students put in into their studies probably will help them to score higher in their exams or in their tests. And so if we want to measure really whether that is true here, then the students' test score will be the dependent variable, and then the number of hours they studied can be the independent variable. By so doing, we'll be able to measure how the effect from um, how the number of hours impacted the scores the students get in their exams. And looking at the model specification for the simple linear regression, we have the dependent variable here. As I mentioned before, is the exogenous variable. We have the independent variable, that's the explanatory variable, the intercept of the regression, the slope, and then the error term, which are very important that we need to observe these variables in order for us in the model specification, in order for us to be able to conduct the time series analysis, and also to be able to get probably the result we are seeking for. Then another example of a simple linear regression is estimation of causal relationship between household consumption, expenditure, and household income. Theoretically, like I mentioned before, as household income increases, it's expected that the household consumption expenditure moves within the same direction. So we can also look at this model, the data for household consumption on page 164 in the recommended textbook. And then we'll see the table, the data given there. And So looking at this model specification here, you will see the household consumption and also the income being placed as the independent variable, while the household consumption is the dependent variable. This will help us in to be able to when running the regression or doing the regression analysis, we'll be able to then dictate which one how the impact from income affects consumption, and it will also help us to know that by how much, and depending on the regression we are trying to look at the result, and we'll be able to dictate by how much income has risen and by how much it has also affected the household consumption expenditure. So in specifying our model, this is very crucial in order for us to achieve the best result while conducting time series regression. Then looking at this scatter plot of household expenditure and income, as I explained before, there is a correlation uh, between the variables. When we want to check whether there is a correlation between the variables, we need to watch and check the direction, the movement of the variables involved. In this case is household expenditure and also household income. As we can see from the scatter plots, both the variables are moving within the same direction. So you can see that there is a relationship between the variable, which means they are correlated. But this does not also explain that, okay, income has an impact on household expenditure unless if they are measured, which I'm going to explain in other slides. Then to be able to measure the impacts of the variable, maybe the dependent variable and the independent variable. We use the OLS model. Is an analysis, a regression analysis that can be employed, especially when we have our data. It helps us to check whether there is a relationship between the variable and by how much, but most importantly, it also help us to measure the slope of the line of an estimate in a regression. This help us to, the aim is to find the best fitting line, in a regression. It could be linear regression here. It can also be multiple regression, which I'm going to explain later. Then the ordinary least square model has assumptions, which this assumption needs to be observed in order for us to say that, okay, yes, we've achieved the OLS model within our regression. And this regression, the assumptions are linearity in the parameter of the model, then independence of errors, then we also need to the problem of homoscedasticity. Then there shouldn't be any multicollinearity within the um, variables that we are trying to measure. Also, a zero mean error term. There wouldn't be any endogeneity. Then the variables the errors need to be normally distributed for us to know that we've achieved um, the OLS model assumptions. Okay, I've already explained all these ones. Looking at these scatter plots lines of OLS model using household consumption and household income, one can see that all the variables are aligned, they are fitted within. You can see the model, the variables, even though they are scattered a bit, but when a straight line is being drawn within the scatter plots diagram here, they are well fitted, showing there is a established relationship between the models, and it also aligns with the assumptions of the OLS models, showing that there is linearity. The model, the variables are also independent of errors, and no multicollinearity when two similar variables are being used for the analysis. So one needs to be very careful, especially with the issue of multicollinearity that usually happens within regression. One needs to be careful when selecting the variables to make sure that the variables selected did not maybe they do not have any relationship. They are not similar, and they are not measuring the same thing in the same regression. So we need to be very careful here in order not to have that error in our regression. Then when we are using the OLS model, the ordinary least square estimator, to measure the goodness of the fit, we need to look at the residual sum of square or total sum of square. These are the squares. These are the squares we need to look at in our estimation, which I'm going to show us soon, to be able to make sure that the variables are there's a goodness of fit, and the variables are well fitted, as I explained earlier, within the lines. And this will show us the nature of the relationship between the variables, and also by how much that relationship that exists within the variable. We need to, when we do the regression, we'll be able to look at it and see how the variables, whether the variables are well fitted within the lines or not. So this area of OLS model is also very crucial, especially when we are using the model in our regression analysis. Then there is this Gauss-Markov theorem when we speak about the assumptions of the OLS model. The best linear unbiased estimators is also well detailed in the recommended textbook, but somehow related also to the former, to the key assumptions I've already mentioned. These assumptions, they need to be observed when we are using the OLS models in our regression. Then, looking at this, I will go back to the parameters observed from the regression model. But first of all, let's look at this household model, household consumption, a logged household consumption. This is between two variables, as I've explained before, using the linear regression model. You can see that looking at the coefficients, the consumption and also the income, they are highly significant, which shows that the variables there is, first of all, a significant relationship that exists between the variable, and that the household income can also impact consumption. The p-value also states the same thing. So we need, when you are trying to interpret the regression of OLS model, you need to observe and look at the coefficient to make sure that the variables there is a relationship that exists between the variable and is a positive relationship. And by looking at how significant the coefficient of the model is, and also the p-value, all this needs to be observed when we are interpreting the regression from the OLS model, and it will also help us to in analyzing the results we see here. And looking at this is a log of consumption and also that of income from household. And we can see from the equation 7.10 in the recommended textbook that there is a 1.26 1.26 like consumption increases by on the average, say by 1% when income increases, when income increases by 0.8% in the regression analysis. So we need to look at it like that and be able to use it to interpret the results from the variable. And again, as I've explained before, obviously, when you are doing a regression analysis using time series analysis, you can, though, especially those that are in data science, sometimes they want to measure between two variables and they can be able to do the regression using just the two variables and they will also get a positive result. But somehow, that does not really work, especially when you are doing using time series analysis, because you need to measure by how much the independent variable influences the dependent variable, and you cannot just use one variable. So some using multiple regression model, you need to also include other variables that are related to household consumption and income. One can consider in this case maybe inflation, interest rates, and other variables that will fit within the regression or within the OLS model that we are trying to measure. And also, as I explained earlier, one needs to be careful in selecting those models and make sure that the model, in selecting the variables, and make sure that the variables are not related to each other. And also, one needs to be careful with the issue of homoscedasticity and the serial correlation. Those are the some of the problems that can arise when we are using OLS model. So we need to look out for it and be able to observe it and know whether the model we are trying to use really fits in within the data, which we are going to actually see very well as we move forward. We can also look at the table of descriptive data for consumption, income, and probably consumer confidence for when we are at the recommended textbook for when we are looking at how the variables relate to each other. We can also have a detailed maybe information from the page with the data they have there. Now, as I explained earlier, when you're using the OLS model, the R square is very important. Likewise, the adjusted R square. This help us to know also how fitted the models used, the models are, or the variable used in the model, how fitted they are, and also it will help us in explaining the results from the analysis. So we need to not just look at the coefficients or the p-values that are obtained from the regression. One also needs to look at the R square and also the adjusted R square. One also needs to be also pay close attention, especially when the R square is very high. When we are doing the OLS model, we need to pay careful attention and also be able to observe how the variables, the movement of the variables as the R square and also the adjusted R square is increasing. We just need to look at them and be able to interpret the results based on the regression or how the variables perform with each other in the regression. However, when we are using this OLS model, as I explained, as I've listed before, the assumptions of the OLS model, I think about 10 of them, needs to be observed, which means that when one of them does not align with the regression results, it means that the OLS result is invalid, like the result does not fit in well into the analysis. Like I mentioned before, there could be issue of serial correlation when all the variables are equals to zero, which means there is no correlation at all within the variable. The variable does not have any relationship. And when things like this happen, it means that the variables we have within the model does not suit in very well in the analysis you are trying to conduct. Maybe you can maybe remove the variables, look at other variables that maybe can fit well within the analysis we are trying to conduct, and also in the regression we are trying to conduct. There could be also the problem of heteroscedasticity, which also makes the result and the regression invalid. There could also be problem of non-normality of residuals. And as I mentioned before, there could also be problem of multicollinearity. All those problems can happen. First of all, depends on how the variable you're using behaves. Like I said before, you need to watch how the variables are behaving. And also that there is a very common mistake people make when they are selecting their variables, or when they are trying to conduct regression, and that is knowing which variable is supposed to be the dependent variable, and also which variable is supposed to be or variables are supposed to be the independent variable. So all those things are, one needs to pay close attention to understand the research they are trying to conduct. Like I mentioned in the previous lesson, when you understand the scope of your research, also understand your research question, you build your research aim from there. That will help you to know the variable that will fit in within your model, and also the one that are supposed to be the dependent variable, the independent variable. And also when even when you finish conducting the regression and in your analysis, it helps for you to be able to interpret the result based on the scope, your research question, and the aims you're trying to achieve within the research. One needs to pay close attention in all these things, because when you have problem of maybe multicollinearity, that the variables are closely related to each other, it means that the result is invalid, or you can even your regression and the result does not fit in well. And when you present such, it will not make sense. Based on maybe it could not even make sense, and it can also not relate to maybe the a priori expectation or the theoretical framework one is trying to look into or is trying to observe in the analysis. So these are the place a researcher needs to place close attention in order not to fall into the problem of those the OLS assumption. Now, when handling your time series data, as we usually do, before you start your regression, you need to check whether the data is stationary or not, by conducting the unit root test. When you conduct the unit root test, it helps one to understand that whether, okay, what methodology will fit into this study. Well, if the OLS model, the assumptions of the OLS models are not observed, what other methodology can one adopt in order to carry on with the research? So we have the one can say, okay, let's adopt the univariate analysis where we have the autoregressive univariate, but first of all, you need to look at the model. In some cases, when the data is stationary, all the data or all the variables we are using in the analysis are stationary, one can look at it and say, okay, we can adopt maybe the error correction model listed here for the regression, or if the variables are not stationary, all the variables are not stationary, one can adopt the methodology, the autoregressive distributed lag methodology that can fit into the model. So we need to pay close attention to how the variables, how the data is behaving, when we start our regression, especially at the initial stage of the stationary, trying to test for stationarity in the variable, one needs to check that. You can also look and check whether maybe the moving average processes can fit into your data. Then the issue of autoregressive moving average, where you observe the Jenkins methodology in model building and forecasting. One needs to know whether they fit in, your data fit in into these steps. And also the issue of ARC-GAC models, they can also be adopted depending also on how the variables are behaving. Which is why I said that one needs to pay close attention at the initial stage in order to make sure that the variables are responding well to the methodology we adopted in our analysis, in order for us not to fall into maybe the problem of spurious regression or other problem that can arise because the variables does not fit in well into the model. As I've explained before, the looking at this framework here, those are the steps you need to look into when you're using the time series model. When the OLS model, the assumptions does not fit in well, you need to look at the variables very well to know um, the model or the methodology that suits in well into your analysis. We also have the bivariate and multivariate analysis, where we use the vector auto regressive model, as I've explained before, when we are doing the regression, and also observe the bivariate case and the multivariate case. Then we look at the framework for choosing time series method based on data properties, which I've somehow explained before. Here we start from the unit root. We can do the ADF of the Philippe-Perron or the KPSS, depending. And again, this is time series data. We are working with time series data, and also the one need to be very, very careful to observe the data very well because of the problems associated with time series data, and also depending on whether the model, how well the model suiting. As I explained before, you can adopt the error correction model, and also when the error correction model do not work, you can also adopt the vector error correction model in the analysis, and that is it. Thank you, everyone, and let me know if there is any question so far.
Okay. Hello, everyone. All right. I don't see any hands at the moment. So I think we can then just move to the last part of this session. So I'm going to play a recording of the next section, which is the qualitative research methods.
Okay.
If you
Thank you very much.
Okay, if you do have questions on this topic still, then we can reserve some space at the end of this session. All right.